Hi everyone. Okay, so this is kind of it with the rules. This is as hard as it gets. So the chain rule is going to be combined now with the product rule and the quotient rules. So our learning goals are learning to differentiate complex functions that require a combination of more than one rule. And we're also learning to simplify the derivative so it's expressed in simplified factored form. So this first part is going to be the calculus. And the second part is algebra. And they're kind of equally important here. And often the calculus everybody's fine with. It's the algebra part that bogs people down a bit. So hopefully I've got some strategies that will help you be able to put these in simplified factored form. True story, like first year calculus midterm for me was all multiple choice, and you would get a question like the ones I'm going to show you today and just 4 final answers, and you would have to do all the work that it takes, and you'll see that it takes a bit of work to get these into simplified factored form to figure out which one was the correct answer. All right, so first question, find the derivative in simplified factored form. So the first thing you're going to have to do is kind of recognize this as a product rule question. And how do I do that? So you want to think about it as this is one function of x multiplying by another function of x here. So we've got a product rule. So when you have a product rule, you're going to do your little chart here, and the chart is way more helpful when you've got like a very complex question like this than when you have an easier one. So our first function is x squared plus 1 cubed. And our second function is 2 minus 3x all to the 4th. Now we're going to take their derivative, so that involves the chain rule. So the derivative of the first function is going to be 3 times x squared plus 1 squared. And then remember we take the derivative of what's inside times 2x. But then I want to simplify that down as much as I can before I go over and use the product rule. So these are monomial terms, so I can multiply them together. So really I've got 6x times x squared plus 1 squared as my derivative. Similarly over here, to take my derivative, it's also going to involve the chain rule. So it's 4 times 2 minus 3x cubed. And then the inner derivative, the derivative of 2 minus 3x is negative 3. And then those two terms can be multiplied together. So I've got negative 12 times 2 minus 3x all cubed. So here's my corresponding derivatives here. So then in my first line, I start way at the side here. So y prime equals the derivative of the first times the second. So I'm going to look at these two kind of carefully. Any monomial terms I'm going to put in the front. So the 6x is going to go in the front. And then times my x squared plus 1 squared times 2 minus 3x all to the 4th. So kind of like these 3 chunks here are all multiplying together in my first term. So product rule, derivative of the first times the second plus the first times the derivative of the second. So again, I'm going to look through these. Here's the first, here's the derivative of the second. There's a monomial there. So I want to write that first, and it's negative. So I'm going to change this plus to minus 12. And then it doesn't matter what order you put these in because they're all being multiplied together. So 2 minus 3x all cubed times x squared plus 1 all cubed. All right, so that is the derivative. There's the calculus done. Calculus done, step 1. Anything else that comes along further is doing the algebra that puts it into simplified factored form. Okay, so what I want you to think of this of right now is as 2 big terms. So this big term and subtracting this big term. And we want to common factor. So the first thing we're going to do when we're common factoring is compare our monomial terms, 6x and 12. And what's in common with them is 6. Then we're going to compare our x squared plus 1 terms. So we've got x squared plus 1 to the power of 2 and x squared plus 1 to the power of 3. So we want to take the 1 just like when in common factoring normally with a smaller exponent. So we're going to take x squared plus 1 squared as part of our common factor. And then we're going to look at our 2 minus 3x terms. So we've got 2 minus 3x to the power of 4 and 2 minus 3x to the power of 3. So we're going to take the one with the smaller exponent, which is to the power of 3. And then I kind of use a square bracket to remind myself that I'm common factoring this out of this. So I'm thinking to myself, if I take this term here and divide it by the greatest common factor, what would I get? So I'd have 6x divided by 6. That's going to give me 6. Okay? Then I've got x squared plus 1 squared divided by x squared plus 1 squared. So they're exactly the same. So when they divide out, they give me 1. I don't need to show that. 6 times 1 is still 6. Now I've got 2 minus 3x to the power of 4 divided by 2 minus 3x to the power of 3. So just because this is the first time we've done it, 2 minus 3x to the power of 4 divided by 2 minus 3x to the power of 3. Okay, so by the exponent rules, you keep the bases are the same, and subtract the exponents. So that should give me 2 minus 3x to the power of 1. Okay? So I'm going to use a bracket here. 6 times 2 minus 3x to the power of 1, which I don't need to show. So now I've divided this first green chunk by the greatest common factor. Now I'm looking at the second green chunk, and I want to divide it by the greatest common factor. So I'm thinking about this negative 12 divided by 6. That's going to give me negative 2. 2 minus 3x to the power of 3 divided by 2 minus 3x to the power of 3. So they're exactly the same, so they're going to divide to give me 1. X squared plus 1 all cubed divided by x squared plus 1 all squared. So again, similar to this one, x squared plus 1 all cubed divided by x squared plus 1 all squared should give me x squared plus 1 to the power of 1. 3 minus 2. Keep the base, subtract the exponents. Okay, so notice that we're changing two huge terms here separated by subtraction. So a difference, we want to change it so that it's in factored form, which means in the end everything will be multiplied together. So we've got a 6 multiplying by an x squared plus 1 squared, multiplying by a 2 minus 3x cubed, multiplying by whatever this turns out to be, and it's simplified factored form, not just factored form. So I've got to simplify what's in this square bracket. So that's going to give me 12 minus 18x. So I'm distributing the 6 minus 2x squared minus 2. Keep going. So then I would organize it, because I see there's an x squared and x in plain numbers, so that I have my x squared term first, followed by my x term, followed by 12 minus 2 is 10. Okay? Now, that before you're done, you have to check and see, is this bracket where I common factored out of, once I've simplified it, can it be factored? Well, all of these terms are divisible by negative 2, first of all. So I'm going to take the negative 2 out. So I'm going to use square bracket again, so you can see carefully what I'm doing here. So I'm common factoring negative 2 out of this trinomial. And I'm going to get x squared minus, so negative 18 divided by negative 2 is positive, 9x. minus 5. And then this is a monomial and everything's multiplying, and this is a monomial, so they can be multiplied together and put at the very start. So 6 times negative 2 is negative 12. And then times x squared plus 9x minus 5. And then you would also check and then see if that trinomial could be factored. Okay, that'd be your very last step, but in this case there aren't two numbers that multiply to negative 5 and add to positive 9. So this is simplified factored form, as simplified and factored as you can get. And notice you've got 1, 2, 3, 4 things all multiplying together. Instead of when we just done the calculus, we have two big huge terms subtracting each other. So that's not considered factored form. And then we got it into factored form, but then we had to simplify it by doing the distributive property and then seeing if what was left could be factored further. Okay? All right. Next question. So B, f at x equals 2x minus 1 times, divided by x plus 2 all to the 6th. So you can do this question in two ways. I like to see it as it's a chain rule first, and then with a quotient rule inside. And then other people would want to rewrite it like this. And say that it's a quotient rule first with chain rules to do in each place. We will see one similar to this where the exponents aren't the same, and then you'll have your decision to make on which way you like to do it better. But for a question where it's a quotient all to one exponent, I like to do a chain rule first. Okay, so you're gonna hopefully see my technique for this. So I'm starting off f prime at x is equal to, so following the chain rule, the 6 comes down, times the whatever, all to the 5th. Okay, but then I have to multiply by the derivative of what's inside. That's what the chain rule says. So I have to multiply by the derivative of what's inside here. And to get the derivative of this, that's where I have to use the quotient rule. So first, second, function, derivative. But I'm just looking, so my first is 2x minus 1, because I'm just deriving what's inside here, the inner derivative, using the chain rule. And my second is x plus 2. And the derivative of the first is just 2, and the derivative of the second is just 1. Okay, so quotient rule, derivative of the first times the second. So it's going to be 2 times x plus 2, and then there's minus the first times the derivative of the second. So that's going to be minus 1 times 2x minus 1, all over the second, which is x plus 2 squared. So there's the calculus. We've done the calculus. You found the correct derivative, but now you have to put it into simplified factored form. So I've got the 6. 6 is going to be in the numerator. And then I am now going to write this as 2x minus 1 to the 5th being in the numerator, and x plus 2 to the 5th being in the denominator. So that's kind of this chunk here rewritten. Okay, so now I'm going to keep going with the square bracket here. So I'm going to distribute in the numerator. There's really a 1 there. So I'm going to get 2x plus 4 minus 2x plus 1 over x plus 2 squared. So here's the quotient rule part, and here it is a step below, just with the expanding done. F prime at x. So now I'm going to try to make a full a numerator and a denominator. So 6 times 2x minus 1 to the 5th times, so then looking here in the numerator, 2x minus 2x is 0, 4 times 1 is 5. And then in the denominators, if you notice, this is x plus 2 to the 5th being multiplied by x plus 2 squared. So I'm multiplying powers that have the same base. The base is x plus 2. So the rule for multiplying powers with the same base is to keep the base and add the exponents. So I really have x plus 2 to the power of 7 in the denominator. And I'm almost done. It's just that the 6 and the 5 are both monomial terms, so they can be multiplied together. So I have 30 times 2x minus 1 to the 5th all over x plus 2 to the 7th. And there it is in simplified factored form. Simplified factored form. Okay, next one. So it looks harmless enough, but here we see that we have x, so a function of x, multiplying by another function of x. So first I'd probably maybe rewrite it or just go to my chart, but x times x squared plus 1 to the 1/2. So I know it's a product rule, but because of the x squared plus 1 to the 1/2, the chain rule is going to be involved as well. So I've got my chart, first, second, function, derivative. So my first function is x, and its derivative is 1. My second function is x squared plus 1 to the 1/2, and the derivative of it using the chain rule is going to be 1/2 x squared plus 1 to the negative 1/2 times the inner derivative, which is 2x. But then 2x and a half can be multiplied together to just give plain x times x squared plus 1 to the negative 1/2. Okay, so now I can do my product rule. So y prime, derivative of the first times the second, so that's just going to be x squared plus 1 to the 1/2. Product rule plus the first times the derivative of the second. So if you see, when we're multiplying the first and the derivative of the second, we can multiply the x and the x together and get x squared. Still multiplying by x squared plus 1 to the negative 1/2. So here it is, that's my derivative. My derivative's done, but now I have to put it into simplified factored form. So to do that, I've got my two big terms here. Here's my first one, separated by a plus sign. Here's my second one. So I've got to look for the greatest common factor. So here I don't have a monomial. Here I have an x squared. So neither one of those is, there's no common factor there. And then I'm looking at my x squared plus 1s. So they are the same, and I'm going to take the one with the smaller exponent. So what's smaller, a half or negative 1/2? It's negative 1/2. All right, so here's where exponent rules come in. So I want to divide x squared plus 1 to the positive 1/2 by x squared plus 1 to the negative 1/2. So x squared plus 1 to the positive half divided by x squared plus 1 to the negative half. So I'm using the rule where I'm dividing powers with the same base. So I keep the base, which is x squared plus 1, and I subtract the exponents. So it's going to be a half subtract negative 1/2. Subtracting a negative is the same as adding, so I end up with x squared plus 1 to the 1. A half plus a half is 1. So that works out really nicely. So when I divide this by the greatest common factor, I just get x squared plus 1. Now I want to divide this chunk by x squared plus 1 to the negative 1/2. So you can see that the x squared plus 1s to the negative 1/2s divide out when I divide. So I'm thinking about this term here, x squared times x squared plus 1 to the negative half divided by x squared plus 1 to the negative half. Because when you're common factoring, you're dividing. So those divide out because they're exactly the same, and I'm just left with x squared. So that's going to be plus x squared. All right, so I've got x squared plus 1 to the negative half times, simplify inside this bracket here, 2x squared plus 1. But my final answer shouldn't have negative exponents, and it should have radicals where it's important to. So in the numerator is going to stay my 2x squared plus 1, but the denominator is going to become, because I'm moving this down to make the exponent positive, but the exponent of a half is the square root. So it should be 2x squared plus 1 over the square root of x squared plus 1. And there it is in simplified factored form. Okay, next one. Okay, so now we're kind of on, this is probably the hardest one you can get. This would have been if we were in regular calculus on the rules, this would be the part D question. So if you can do this one, you got the rules down. So if you notice, we've got a quotient rule here first. Within the quotient rule, there's going to be a chain rule involved, but we've got a quotient rule. So we're going to do our first second function derivative chart over here. So my first function is 2x plus 3 all cubed. And my second one, instead of writing square root of 4x minus 7, I'll write 4x minus 7 to the half. So there's my first and my second. First is whatever's on the top, second is whatever's on the bottom. Now I'm going to do the derivative. So the derivative of the first is going to involve the chain rule. So 3 times 2x plus 3 to the power of 2, and then times the inner derivative, which is 2. Simplify, and you get 6 times 2x plus 3 squared. Derivative of the second, chain rule again, so half times 4x minus 7 to the negative 1/2 times the inner derivative, which is 4. And then you can multiply a half and 4, and you'll get 2. So then we have our functions and derivatives. So those match up and these match up. So then I'm going to do my quotient rule. So g prime at x. So for the quotient rule, it's derivative of the first times the second. So look at both of them. Do either of them have a monomial? Yes. So that's going to go first. 6 times 2x plus 3 squared times 4x minus 7 to the half. And then minus, because it's a minus in the quotient rule, minus the first times the derivative of the second. But this one has a monomial, so it's going to go first. 2 times 4x minus 7 to the negative half times 2x plus 3 cubed. Quotient rule. And the quotient rule has all over the second, which is 4x minus 7 to the half squared. Okay, so there's the calculus right there. I've done the calculus. Everything that follows now is algebra to put it into simplified factored form. Okay, so in the numerator, we're looking at two big chunks here, this chunk and this chunk. And we were looking for the greatest common factor in the numerator. So I'm going to compare the monomials first, 6 and negative 2, so 2 is in common. Then I'm going to compare the 2x plus 3, so I have 2x plus 3 to the power of 2 and 2x plus 3 to the power of 3. So I keep the one with the smaller exponent as part of my greatest common factor. Then I'm going to compare the 4x minus 7s. So 4x minus 7 to the negative 1/2 has the smaller exponent. So there's my greatest common factor. So I'm going to open up a square bracket, and then I'm thinking about dividing this green chunk here that's in the numerator by this greatest common factor here that I've figured out. So I'm doing 6 divided by 2 is 3. 2x plus 3 squared divided by 2x plus 3 squared is 1. 4x minus 7 to the positive half divided by 4x minus 7 to the negative half. So again, we've learned how to do that. 4x minus 7 to the positive half divided by 4x minus 7 to the negative half. So we're dividing powers with the same base. So we keep the base, subtract the exponents, gives me 4x minus 7 to the 1. So when I divide these, I'm going to get 4x minus 7. So bracket 4x minus 7. So this part here is me dividing this by the greatest common factor. Okay, so this divided by this gives me the 3 times 4x minus 7. Now I'm going to divide the second green chunk by the greatest common factor. So negative 2 divided by 2 is negative 1. 4x minus 7 to the negative half divided by 4x minus 7 to the negative half. They're exactly the same, so that gives me 1 again. 2x plus 3 cubed divided by 2x plus 3 squared is going to give me 2x plus 3. Close my square bracket. So now I've common factored the numerator. In the denominator, what can I do? Well, I've got a power to another exponent. So you keep the base for exponent rules and multiply the exponents. A half times 2 is 1. So that gives me 4x minus 7 to the 1. Now I want you to notice something here, and that's that we have a 4x minus 7 to an exponent in the denominator, and we have a 4x minus 7 to an exponent in the numerator. Okay? So as we're going on to the next step, I call these clouds, put clouds around these. I can use exponent rules. So I've got my 2 and my 2x plus 3 squared. Now if I have 4x minus 7 to the negative half in the numerator, and I'm dividing that by 4x minus 7 to the 1 in the denominator, according to the exponent rules, I keep the base and subtract the exponents. So I would change minus 1 to minus 2 over 2, getting a common denominator. So it would end up that when I divide those, I keep the base and my exponent becomes negative 3 over 2. Okay? So if I divide the 2 pink clouds here, we just proved that we would get 4x minus 7 to the negative 3 over 2. And then now within these square brackets, we're going to distribute and simplify. So I'm going to get 12x minus 21 minus 2x minus 3. I've used up that 4x minus 7 that was in the denominator because I did the divide. But now I do want to sort out. I can't have negative exponents, and I need radicals where I need them, and then this part's not simplified. So the 2 is going to stay in the numerator, 2x plus 3 squared will. But this 4x minus 7 has a negative exponent, so it's going to move to the bottom so that it has a positive exponent. And then in here, I'm going to collect. So 12x minus 2x is 10x. Negative 21 minus 3 is negative 24. Okay, so then I have to check in the part that I simplified in here if it can still be factored. So 10 and 24 are both even, so 2 factors out of there, common factors out. And then the denominator, I would want to write this as the square root, because that's the 2 that's in the bottom of the rational exponent, means square root of, in brackets, 4x minus 7 cubed. So there's my denominator done. Almost done, but this 2 can be multiplied by this 2 out front because they're monomials. So my final answer would be 4, 2 times 2, times 2x plus 3 squared times 5x minus 12 over the square root of 4x minus 7 all cubed. So there's the final answer in simplified factored form, and this would be like a 10-mark question. You can see all the work that goes into it. So again, this work on top, so making the chart and using the quotient rule with the chain rule inside, that's the calculus. And then all these subsequent steps are algebra that we've been practicing over the years: common factoring, expanding, simplifying, exponent rules. All of that algebra is in the rest of the answer to get it into that simplified factored form. Okay, I've got another one like that, but a bit easier because there's no square root involved. So if you want to try it on your own and see if you can get it in simplified factored form, you could pause and then look back and see if you got it. So again, quotient rule first. So we're going to make our chart. So our first function is what's on top, 1 plus x squared to the 6th. And our second function is whatever's on the bottom, 2 minus x squared to the 4th. Now we need the derivative of each, which is going to involve the chain rule. So 6 times 1 plus x squared to the 5th. And then the inner derivative is 2x. A lot of people, that's what they forget. They forget the inner derivative. Please don't do that. Some people find the chart really helpful for that. And then simplify. So 12x times 1 plus x squared to the 5th. And then the second, when we derive it, we need the chain rule again. So 4 times 2 minus x squared cubed times the inner derivative, which is, careful, negative 2x, because the derivative of negative x squared is negative 2x. And then you can simplify that to negative 8x times 2 minus x squared cubed. Correspond. And then we can start our quotient rule now. So derivative of the first times the second, monomial term first. Then there's a minus in the quotient rule, minus the first times the derivative of the second. But you can see that the derivative of the second also has a negative in it in the monomial part. So that negative, so negative times a negative is going to give me a positive. So make this plus 8x times 2 minus x squared cubed times 1 plus x squared to the 6th all over the second squared. So I'm going to use a regular bracket and then a square bracket for squared. Okay, so there's the calculus again. That part was the calculus, and the rest of it's all going to be algebra. So I'm going to look in the numerator at these two big chunks and figure out what the greatest common factor is. So comparing the monomials, 12x and 8x, 4x is in common. Comparing the 1 plus x squareds, the 5th is the smaller one. And the 2 minus x squareds, the cube is the smaller one. So that's my greatest common factor. And I'm going to divide each green chunk by the greatest common factor. So 12x divided by 4x is 3. The 1 plus x squareds cancel out because they're both to the power of 5. 2 minus x squared to the 4th divided by 2 minus x squared cubed is 2 minus x squared. Now we're on to the second one. So dividing positive 8x by positive 4x is going to give me positive or plus 2. 2 minus x squared cubed divided by itself is 1. 1 plus x squared to the 6th divided by 1 plus x squared to the 5th is 1 plus x squared. All over. So this is going to be, you've got a power to an exponent. You keep the base 2 minus x squared, and multiply the exponents. Careful with that rule. Another common error is people adding them, but when it's power to an exponent, you keep the base and multiply. And then we have clouds because we have a 2 minus x squared on the bottom and on the top. So we're dividing powers with the same base as we go through here. So we can keep the base, which is 2 minus x squared, and subtract the exponents, which gives us -5. And then in my square bracket, I can distribute. So that's going to give me 6 minus 3x squared plus 2 plus 2x squared. Keep going. So 4x times 1 plus x squared to the 5th. This one has a negative exponent, so I'm going to move it to the denominator, the positive exponent. And then here, I'm going to collect my 6 and 2, 8 minus x squared. Negative 3x squared plus 2x squared is negative 1x squared. And I can't factor in here. It's not a difference of squares because 8 isn't a perfect square. So that would be your final answer, simplified factored form. All right, next one. So we've got two functions of x multiplying together. So we have a product rule. So my first is x plus 1, and its derivative is easy, it's 1. The second is x squared plus 2x plus 2 to the half. So it's going to involve the chain rule to derive it. So it's going to be a half times x squared plus 2x plus 2 to the negative half times the inner derivative, which is 2x plus 2. So what makes this one a bit harder is that if you see, you can multiply the half, you can distribute it over this binomial. So half times 2x gives you x, and a half times 2 gives you 1. So it gives you this x plus 1 binomial, and then this trinomial that's to the power of -1/2 when you simplify it. And then you have your correspondence. So h prime at x is derivative of the first times the second, so that's just going to be x squared plus 2x plus 2 to the half plus the first times the derivative of the second. So notice that the first is x plus 1, and the derivative of the second also has a binomial x plus 1. So x plus 1 times x plus 1 is x plus 1 all squared, and then times x squared plus 2x plus 2 to the -1/2. So there's the calculus done. Now we're going to do the algebra to get it into simplified factored form. So here's my first big chunk and my second chunk, separated by a plus sign. So I'm looking for the greatest common factor. So the only things in common with these two chunks are the x squared plus 2x plus 2, and I take the smaller exponent, which is -1/2. And now I'm going to divide each green chunk by the greatest common factor. So something to the half divided by the exact same thing to the -1/2. Again, that gives me whatever it is to the +1, so it's going to be x squared plus 2x plus 2 all to the 1. Then plus, so these divide out in the second chunk, left with x plus 1 squared. So I'm going to move this to the denominator and make it square root of x squared plus 2x plus 2. In the numerator, that's where I'm going to expand x plus 1 squared. If you can do that in your head, great. If not, you can take steps here and do the FOIL, which I'm going to show. So x squared plus 2x plus 2 plus x squared plus x plus 1 over the square root of x squared plus 2x plus 2. Collect in the numerator. So we have 2x squared plus 4x plus 3 over the square root of x squared plus 2x plus 2. And then we would check and see if the top, it looks like a complex trinomial, but are there two terms that multiply to 6x squared and add to 4x? Luckily, no, so we don't have to do a decomposition and factor it, because that's unfactorable, so we're done. That would be our solution in simplified factored form. All right, and our last question for today. Find the equation of the tangent line to the curve y equals x to the fourth minus x plus 1 squared times x squared minus 2 cubed at the point -1, -9. So equation of the tangent line, remember, is going to be a y equals mx plus b. And we can find the slope by finding the derivative and substituting in -1. We don't have to simplify it if we don't want to. Since we're just putting -1 in, we might not want to, or we might just like to. Up to you guys. So first, second function derivative, x to the fourth minus x plus 1 squared. Derivative is going to be 2 times x to the fourth minus x plus 1 to the 1 times 4x cubed, the inner derivative, minus 1. And the second is x squared minus 3 cubed. Derivative is going to be 3 times x squared minus 3 squared times the inner derivative, which is 2x. Those can be multiplied to give 6x times x squared minus 3 squared. And then we have our correspondence. So y prime, derivative of the first times the second. So 2 times x to the fourth minus x plus 1 times 4x cubed minus 1 times x squared minus 3 cubed plus the derivative, or the first times the derivative of the second, monomial first, 6x times x squared minus 3 squared times x to the fourth minus x plus 1 squared. So because I'm finding it at -1, if I want to, I could just sub -1 in right now. Or if I wanted to, I could simplify. But I think I'm just going to substitute -1 in right now. So, and then I'm going to think through a lot of it, so watch me as I do it. So -1 to the power of 4, I know that's +1. Then it's minus -1. So minus -1 is the same as +1. Okay, minus a negative is adding. +1 again from here. So there's my first bracket. So there's this done and this done. Now I'm on this third bracket here, so that's going to be 4 times -1 cubed. That's going to give me -4, because -1 cubed is -1 times 4 minus 1. And then now I'm squaring -1, which is going to give me +1. +1 minus 3 cubed plus. So 6 times -1 is -6 times 1 minus 3 squared times 1, again, minus -1 is +1 plus 1 squared. So y prime at -1 is 2 times 3 times -5 times, that's going to be -2 cubed 1 minus 3 is negative 2 cubed is negative 8 plus negative 6 times 1 minus 3 is negative 2 squared, so 4 times 9. 3 squared is 9. So y prime at negative 1 is going to be, so that's 2 times 3 times negative 5 times negative 8 is 240. And then this is going to end up being negative 216. So y prime at negative 1 is 240 minus 216, which is 24. So that means that m tangent, if that's all they wanted, we would know it, is 24, but they want the equation of the tangent line, and they tell us at the point negative 1, negative 9. So we've got our x and our y and our m. Y is negative 9, m is 24, x is negative 1. Find b. Add 24 to both sides, and we get b is 15. So now we can do our therefore equation of tangent line is y equals, so our slope is 24x plus 15. All right, so that is our lesson on combining all the rules. Make sure you do the practice and check your solutions.